In this project, we built an administration system for a housing rental agency, helping their non-tech background staff to interact with the database of the company. Firstly, let's have a brief look at our web page. Here we got 5 main pages. Links that next to the up left banner that named Housing Rental Agency Administration System. Except the home one, the others all refer to corresponding entities in our database, and users can add, delete, or update information in the database through these pages. And at the up right, we have View Tables, which will display the current tables in our database. The main function of this home page is searching for appropriate housing resources. By applying the features, the system would sift out all the resources that satisfy needs input. The specific operation process will be shown later with our codes. I was trying to split the screen so the code and the website can be displayed clearly. The size may differ with a full screen. In our database, pet is a weak entity attached to the entity called tenant. We didn't design its own page to add or delete it. Go directly to the tenant page. Similarly, to view all the current pet information, we need to go to View Table, Tenant Information. In our database, pets are recorded with only species, name, and tenant ID. This table named Tenant with Pet is actually generated by the join query, adding first and last name of the tenant to each pet record. I'll show you how to add a pet to an existing tenant. Draw down to the bottom of the tenant page. We can choose the tenant ID by the drop-down box. After clicking the Add button, the website pops up a notification. Number 7, Tenant's Pet Dodo added. We can see from this table. Of course, we can also add new tenant in the tenant page. To do it, we need to choose the house ID and agent ID. This one cannot be added successfully. Why? Okay, it seems this agent already got enough clients. This pop-out warning functionality is done by an aggregation query with group by, counting how many clients the agent currently have when we input an agent ID. Now we'll just choose another agent. Success! This newly added tenant was automatically assigned an ID, 25. And this is a number generated by our system. We got a getID function which applies to all the other entities as well. It would get the current max ID by this aggregation query, then check if there is any idle number smaller than the max one, and then return to an ID.
To record a new housing resource into our database, we need to go to Housing Resources page, specifying which suburb it locates in, which landlord it belongs to, and some other information. Here we have a selected field for suburb, which is supposed to contain all the suburbs in Brisbane as choices. But there are too many suburbs in Brisbane. Please pretend here we've got everything. In this company, any agent that has house resources in all the suburbs would be mentioned in our homepage to motivate other agents. There is no one at our homepage right now. Let's see what would happen after we add in one more tenant. Then let's back to the homepage. Just under the welcome banner, new information popped up. We are proud of agent number 1's great achievement. That's because we run a division query in the homepage, checking if there are any agents that in all the suburbs have houses that is in charge of her. We just added an house. How about delete a house resource? How about delete a house whose owner has only this one house in our database? Would the landlord stay in the landlord database? Landlord number 2 has only one house whose ID is 5. This landlord is right over there. Let's see what would happen if we delete his only house. Let's check whether the landlord still exists. The landlord has been automatically deleted. This is because we have this trigger in the database. When a housing resource is deleted, it would check if the landlord has any other houses. If not, delete this landlord.
Here we can see, for every tenant, we track which house the tenant lives in by the house ID, which is referenced from ID in rental house table. And we set this one as undelete cascade. That's to say, if the house was deleted, the corresponding tenant would automatically delete it as well. Let's have a try. Now, we have this tenant lives in this house. And then we delete this house. Okay, now this house is not in our database anymore. Let's check this tenant. As we expected, tenant has been automatically deleted. You must have noticed that we got an update section in our agent, landlord, housing resources, and tenant page. This section is to update values for existing entities. Let's take an example on the agent page. Select agent ID. Choose what we are going to update. Input the new value for that attribute, then update. Done. This function is implemented by an update query. For fear that the user inputs some illegal stuff, we have some new value tracking function here to validate the input new value. If you input an invalid email like this one and submit, you get this warning, and this updating would not be success.
Their lines of code connect our web page to our database. Any changes we made on the web would also be done in the database. We implement almost all of the functionality with SQL learned from the lecture, while sometimes the SQL would not be very user-friendly to some non-tech background people. In this project, we built in SQL in the website through Flask, getting to know how to use SQL in a practical way. And we are really lucky to work in a closely connected group. We met regularly, always keep in touch online, and everyone is willing to help.